Now, let's find the domain if I know the range is 6, 7, 8, and 9. What do I do? Take the equation for this problem, put it into the y equals screen so that you can see the x values and y values. Remember, x values are domain values. Range values are y values. Go to the y equals screen. And as you can see, I already have the equation typed in. So let me erase it so you can see me type it. Press alpha, press y equals, press number 1, and then type it in. Put x next to it, then plus 6. Did you notice that after I pressed 2, I had to hit the right arrow before pressing X? If not, the X will be down here with the 2, so be careful about that. Now press second to graph, and we're going to look at the table. I have here that the range is 6 when the X is what? 0. Oh, so here's range, and then here is the X value, because I'm going backwards this time. And then I have, when the range is 7, what's the X value? It is 2. Let me put 2 here. And when the range is 8, what do I put? It's 4. And then for 9, I get what? 6. Now I have exactly what the calculator produced, which is a table of values. Now, I'm trying to write it on the table, but look what I did. I wrote 0, 2. That's not right. Why? Because it's 0, 6. Oh, domain range. So my table up here is actually a horizontal table. So be careful when you see those type of tables. You have to turn it to write it. So this becomes 0, 6, 2, 7, 4, 8, 6, 9. Domain values, range values. So now, why did I do that? Because that table is incorrect. Look at the X values. Do any of them repeat? No, they do not. So this is a function. All right. This is the what? Y-intercept. Look at that. Look, 0, 6, 6, 0, 6. How it's appearing so many times. Look at the slope. It's 1/2. That means Y, the rise, is moving as the run moves too. Rise over run. Well, look at that. Up 1, up 2. 1 over 2. The change in Y over the change in X. Up 1 over 2. Well, now let's look at the change in Y, the rise over run, change in X, on the graph. Here is my y-intercept. It is 0, 6. Make sure you make this adjustment. YouTube viewers, if you want this worksheet, just let me know. I'll make the corrections before giving you access to it. This is 0, and then here is -1. So now I have a y-intercept of 6. 6 is on the y-axis. That's 0, 6. Now move up 1 and to the right 1, 2. Up 1 and to the right 1, 2. Up 1 and to the right 2. That is a slope of 1 over, let me switch pens, 2. Now be careful. When you rise, you are rising using horizontal lines. That's how you find range. Remember? Y over X, the change in Y over the change in X. Here's the run down here. But when you run with vertical lines. That's how you find domain. Let me show you. I went from here to here. That's one loop. That's how I got 1. I went from here to here, from there to there. That's 2 loops. So I went up 1, and then I went to the right 2. One more time. Up 1, just like that. Up 1, and then to the right 2. Okay, moving on. In this problem, it says, again, find slope and find the y-intercept. But it's not solved for y. So how do we do that this time? Subtract 4x. Why? Because he is positive, which means if you were given a problem like this, just in case, because we don't know what the benchmark is going to have on it. If you were given an x term that was negative, what would you do? You would add it. And be careful, that does not become 16. That's 4x plus 12. And that's when the slope would be 4 because it's negative on the other side. But in this problem, it starts off positive. So m is not 4. M would be negative 4.